Let's go over some geometric sequence basics. So the first thing here we have is we're going to identify whether the following sequence of values is arithmetic or geometric. So it's probably a good idea just to have a basis of what in the world does it mean to be arithmetic and what does it mean to be geometric. So when a sequence is arithmetic, what that means is you're going to add or subtract the same value over and over. So you go from one term to the next, you're going to add or subtract that same number every single time. We're geometric, we're going to multiply or divide by that same value every single time. So there are some ways for some students they can look just at the sequence and quickly figure out if it's arithmetic or geometric. Others, they can't just look at it and they need a little bit of help, so I'll show you that as well. So looking at this first one, we go from 3 to 6 to 12 to 24. One thing I noticed is these numbers get really, really big fast. We went from 3 all the way to 24 real fast. That kind of lends me to believe it's geometric. Here's how you can check, and this is going to work the same way with arithmetic. We're going to start from the right and work our way to the left. And what we're going to do is we're going to take the right number, which in this case is 24, and divide by 12. 24 divided by 12, that gives us 2. And we're going to keep working our way back. So then let's take 12 and divide by 6, and we get 2. 6 divide by 3, and we get 2. Notice how it's the same number every single time. And I divided there, so notice how that's kind of that's a geometric type thing. So now let's use that 2 and look at, well, how can you go from 3 to 6 using 2? Well, 3 times 2 is 6. 6 times 2, 12. 12 times 2, 24. So I know this first one is geometric, and the reasoning is we multiply by 2. So if we take a look at this right one, we go, the sequence is 8, 6, 4, 2, 0. So again, for a lot of students, this might be real obvious that it's arithmetic or geometric. Things I see is it goes 8, 6, 4, 2, 0. In the grand scheme of things, not getting very big very fast or very small very fast, that would hint at geometric. It's kind of going a very basic pattern which suggests linear. So what I'm going to do is, over here I did right divided by left, right divided by left. Since I think it's arithmetic, let's do right minus left. So 0 minus 2 is negative 2. 2 minus 4, negative 2. 4 minus 6, negative 2. 6 minus 8, negative 2. So using that, let's look at it at an arithmetic piece. Well, how do I go from 8 to 6? Well, add negative 2. 6 plus negative 2 is 4. 4 plus negative 2 is 2. 2 plus negative 2 is 0. So this is arithmetic, and the reason is we add negative 2. You could also say subtract 2. That works as well. The next piece we're going to look at here is find the next 3 terms of the geometric sequence. So we go 5 to negative 10 to 20, 20 to negative 40. So they already told us it's geometric. So what I want to know is figure out what's the pattern here. So since it's geometric, I'm going to do kind of like what I did on this problem. Let's take right, divide by left. So I'm doing negative 40 divided by 20. And I get negative 2. 10 divided by 20 divided by negative 10 is negative 2. Negative 10 divided by 5, negative 2. So let's think, how can I use a multiplier of negative 2 to do this? So 5 times negative 2 is negative 10. Negative 10 times negative 2 is 20. 20 times negative 2 is negative 40. So I've kind of picked up the pattern, and that's what I like to do first, is we're multiplying by negative 2. So I like to pick out the pattern first, and now I can figure out the next 3 terms. So if I take negative 40 times negative 2, I get 80. And then if I take 80 multiplied by negative 2, I get negative 160. Negative 160 times negative 2, I get 320. So the next 3 terms are 80, negative 160, 320. The last little example I want to show here with the basics of geometric sequences is we're going to find the equation of the geometric sequence, then find A7. Now before I jump into this, what I mean by the equation is we're going to look at this right here. We're going to figure out AN equals A1 parentheses R raised to the n minus 1. And the key pieces here is A1 represents just what is the first term. And R is going to be our multiplier. And I'll explain here in a second once I get through this. Why is this important to us? So the two things I care about is I want to know what the first term is and know what the multiplier is. So looking over here, I know the first term, well, right there, it's the first term, 128. I just got to figure out the multiplier. So again, I like to work my way right to left. So 16 divided by 32 gives me 0.5. 32 divided by 64, 0.5. 64 divided by 128, 0.5. So I know my R is 0.5 and I found my A1. So I'm going to put this all together. I'm going to have AN equals, instead of A1, let's put 128. And then I need parentheses 0.5 raised to the n minus 1. Now here's why this entire idea of the equation of the geometric sequence is important. In this previous problem, to find the next term, I had to keep continuing the pattern. Multiply by -2, multiply by -2, multiply by -2. Down here, when you have an equation, you don't have to find the next several terms in the sequence. If I want to find A7, which that would represent with the 7 there, the 7th term, well, notice how my n got replaced with 7. So instead of listing out all 7 terms, what I could do is replace my n with 7. So I'm going to do that over here and replace my n with 7. So I have 128.5 in the parentheses raised to the 7 minus 1. And you could take a graphing calculator, plug this all in, and when you hit enter, you should get 2. So I didn't have to continue the pattern. I found out what the 7th term is. It is 2. And that was some geometric sequence basics.